So in this lecture, we'll see how we can perform the manual calculation for the seismic load according to the ASCE 760. For the seismic force calculation, we are going to use equivalent lateral force procedure. So the step number one will be to determine the seismic force parameters. Like we'll require the risk category of the building, okay, and we can get that from the table number 1.51. Then after we will require the importance factor, okay, depending on the function of building. Okay, we have a different importance factor for the particular building. So we can get to know that from the table number 1.52. And there is a response modification factor. It depends on the type of frame that you are going to use for the building design. So we will get to use this response modification factor from the table number 12.21. Then after there is a site class. Okay, like site class is basically nothing but the soil type, you can say, whether the soil is a medium steep or a soft soil. Depending on that, we have the site classes. So we have to calculate that one from the table number 20.31. Then after SS is there, which is the spectral response acceleration parameter at the short period. So this value basically we are going to calculate from the Dubai Building Code 2021. Okay, NFA also, which is the short period of the sweat coefficient. Okay, and it is mentioned in the table number F15 of the Dubai Building Code 2021. Then after SMS is there, which is the spectral response acceleration parameter again at the short period. Okay, so we will calculate that from the ASCE 716 section number 11.4.4. Then after SDC is there. So SDC is the design spectral acceleration parameter from the section 11.4.5 AS system. We have to calculate that. Now, once we calculate all the seismic forces parameters, we have to calculate the seismic response coefficient, which is the CS. So here you can see section number 12.8.1, okay, which says that the seismic base shear. Seismic base shear is nothing but the base shear, which is like the earthquake force at the base of building. Nothing, base is nothing but the foundation level. Okay, so seismic base shear is the shear force like the seismic force at the base of building. Given in the direction shall be determined in accordance with the following equation. So this is the equation to determine the seismic force at the base of building. So formula is like V is equal to CS multiplied by W. Here C is nothing but the seismic response coefficient. Okay, and in order to calculate the seismic response coefficient, we will require all these parameters. Okay, like we have seen this. Okay, so we will require the seismic force parameters. Okay, so to calculate the CS, which is the seismic response coefficient, we will require all these parameters. Then after, the next thing we need to determine is the W. W is the effective seismic weight of building. Okay, so we can calculate the seismic weight of building from the section number 12.7.2. So these are the tips which are included to calculate the seismic base shear, nothing but the, you can say, the earthquake force at the base of building. So we have, okay, and the problem statement you can see is the consider a G+5 story RC office building as shown in the figure. You can see the building is located in the Dubai and the soil condition is steep. Okay, and the dead load on all floors is a 15 kilonewton per meter square and the live load is 12 kilonewton per meter square. The location is given for the building. Then after the soil condition is given, which is the stiff. Then after the dead load is given on all floors and the live load also given. So using the dead load and the live load and according to the area of the building, you have to calculate the seismic load. And according to the location of building, okay, and according to the configuration of building, you have to determine the seismic forces parameters. So in the seismic forces parameter, the first thing we need to determine is the risk category of the building. Okay, so first of all, you can see this is the building configuration. This is the plan view in which the horizontal dimensions are mentioned. Like you can see the width of building is a 15 meter and the length is 25 meter. And in the elevation view, you'll get the height of every particular story in the building. So according to this plan view, you can calculate the width and the length of building. And according to the elevation view, you can calculate the elevation height of every particular story and the total height of building also. Now, the first step in order to determine the seismic force is to calculate the seismic forces parameter. So the first parameter here is risk category of the building. So we'll calculate the risk category from the table number 1.51, which is on the page number 4. Okay, we have already discussed this risk category for the various buildings. Okay, like we have the 4 risk categories: category 1, 2, 3, and 4. Okay, so we'll just briefly go through it and we'll select one category for the seismic forces design. Okay, so you can see this is the table number 1.5. Okay, so risk category 1 is for the building and other structure that represented low risk to human life. Okay, this is for the agriculture facilities, you can say, or for the temporary steel structures. Okay, and this category 2 is for the buildings which are not included in the risk category 1, 3, and 4. So 2 you have to select like for the buildings which are not included in the risk category 1, 3, and 4. And the risk category is 3 is for the buildings which are going to have the substantial risk in the human life during the seismic actions. So those buildings include like the, you can say, residential building and commercial building which are having the higher amount of occupancies, like higher amounts of paper. And the risk category 4 is for the government buildings, or you can say the buildings which are going to have the manufacturing, okay, processes, handle, stores, use, okay, or you can say the hazardous fuels, okay, chemicals and all. So for these operations, you have to use the risk category 4 for those particular buildings. And for the residential or commercial building, you have to use risk category 3. So here in the problem statement, it is given that this is the office building, which is nothing but the commercial building. So risk category will be 3 only. So the next factor we have to determine is the importance factor. And this one depends on the function of building. Now the importance factor you can calculate from this table number 1.52, which is on the page number 5 of the ASCE 7. So here, as we have selected the risk category as a 3, and in order to determine the seismic forces, we have to look for the seismic importance factor. And here for the risk category 3, the importance factor is 1.25. Right? So here in the Excel sheet, we have taken 1.25. Now the third parameter we have to determine is a response modification factor, which is also called as a R. Okay, and we'll calculate that from the table number 12.21, which is in the page number 90. This response reaction factor, modification factor, basically depends on the type of frames you are going to use. Also, it depends on the system, like the building system, whether you are going to use a building frame system, bearing wall system, or you are going to use a dual system. Okay, we have already discussed about this one, but first we'll just overlook into this. Movement resisting frames system will be there when we are going to use a columns beams for the lateral forces resistance. Okay, so you have to go with the C, which is the moment frame resisting system. Now the dual system is there. So dual system we have to use when the building consists of shear wall, columns and beams. Okay, that is the thing. So as of now, you can see in the plan view only columns and beams are there. So you have to go with the moment resisting frame system. And then after you have the following movement frames. Okay, like you can see the steel spatial movement frames. Okay, steel spatial thrust movement frames. Then intermediate reinforced concrete movement frames, ordinary reinforced concrete movement frames. According to your convenience, you have to select any particular building frame system. Okay, like the moment resisting frame system. So for this one, we are going to use ordinary reinforced concrete movement frames. So we are going, this is the RC building, right? So it is a concrete structure. So we have to, what you can do is, you can either use intermediate reinforced concrete movement frames, or you can use the ordinary reinforced concrete frames. The difference is intermediate reinforced concrete frames will consume more amount of steel as compared to the ordinary reinforced concrete frames. Okay, so intermediate resisting frames you can use when the building is going to be located on the higher seismic zones. Okay, when the earthquake forces are maximum in the particular seismic zones, in that case you can select the intermediate reinforced concrete frames. Okay, and if the amount of seismic forces is less, okay, like the building is located in the lower seismic zone, then you can go with the ordinary reinforced moment resisting frames. So here we'll proceed with the ordinary moment resisting concrete frames only, because to achieve certain economy, or you can say to just reduce the amount of steel consumption in the structural design, we have to use ordinary reinforced concrete movement frames. And for those, the response reaction factor, or you can say the response modification factor, is here. So this is the column for the response modification factor. Okay, and as we have selected the ordinary reinforced concrete frames, okay, the response modification factor is 3. Okay, so the same we have taken in Excel sheet also. Now the next step will be to determine site class. So for the calculation of the site class, we have to refer to table number 20.3, which is on the page number 204. Okay, so this is the table number 23.1, which is give you the value for the site class. Okay, so if your building is going to be constructed on the hard rock, then you have to go with the site class as a. And if the building is going to be constructed on the rocks, okay, so you have to go with the site class as a B. And if the building is going to be constructed on the very dense soil, or you can say the soft rock, then site class will be C. Okay, and if the building is going to be constructed on a steep soil, then the site class will be D. Okay, and in the case of soft clay soil, the site class will be E. And for the soil require the seismic response analysis. Okay, this will be done by the geotechnical engineer only. So for those, like if there is a very weak soil, okay, so you have to go with the site class as a F. Okay, and in the problem statement, it is mentioned that the soil condition is a steep. So for the steep soil, the site class is a D, right? So in the Excel sheet, we have taken the site class as a D. Now the next parameter we have to determine is ASCE and FA. Now the ASCE and FA value we can get from the table number F30 of the Dubai Building Code 2021. Okay. So for the location Dubai, you can see ASCE is given, S1 is also there, and TLE is also there. So for now, we require the ASCE only, and the value for the ASCE in the case of location Dubai, you can see it is 0.51. So here 0.51 we have taken. Now the next thing we need to determine is the FA. Okay, this is ASCE and FA. These are the seismic coefficients only, using which you will get to calculate what will be the amount of seismic force that will be applied on the building. So FA we can calculate from the table number F14 of the Dubai Building Code only. So this is table number 13, and here is a table number. You can see table number 14. Okay. So for the site class D, FA is 1.392. Or what you can do is, if you don't want to refer the Dubai Building Code, we have already applied the seismic force in the ETAS model. So you can just go for the load patterns. Okay, and you can modify any particular seismic load pattern. Just modify it, and here you will get to know the value of FA and SS also. Okay, so you can see SS here is 0.51, which we have already taken from the Dubai code only, and FA is already taken, okay, from the code ASCE only, according to the site class we have taken. So you can use the ETAS model also in order to determine the SS and FA. So FA is 1.392 for the site class D. So here, now the next thing we need to determine is a SMS. Okay, now there is a formula for the SMS, which is mentioned in the code. Okay, so it is mentioned in the section number 11.4.4, which is on the page number 84. Okay, so you can see this is the formula for the SMS, which is mentioned in the section number 11.4.4. So the equation is like SMS equal to FA multiplied by SS. Now in the previous, we have just calculated the SS value and FA value. So using that, the Excel sheet will automatically calculate the value of SMS. Okay. Now the next thing we need to determine is the SDS, which values depends on the value of a SMS only. Okay. So formula for the SDS is here only in the section number 11.4.5. You can see SDS is equal to 2 by 3 multiplied by SMS. So once we get the value of SMS, the SDC value will be automatically generated into the Excel sheet. So in the step number 1, we have calculated all the seismic parameters which are required to calculate the seismic force. Now the next thing we need to calculate is a seismic response coefficient, which is the CS only, and the formula for the CS, it is mentioned in the section number 12.8.1.1, which is on the page number 101. So for the calculation of the seismic force, we'll require two parameters basically, the CS. Okay, and right now we are going to calculate the CS only. Then after we'll determine the W. Now here is a formula for the CS. You can see CS is equal to SDS upon R upon I. Here SDS we have just calculated in the step number 1. Then after R is nothing but the response modification factor. We have already calculated that, and it is 3 only. Then after I is nothing but the seismic importance factor, which we have calculated as a 1.25. So for the calculation of CS, we have all the values. Now, once you specify all the seismic forces parameter, the CS value will be calculated in the Excel sheet only using this formula only. Okay, so you can see the formula I have mentioned in the Excel sheet only. It will be automatically calculated. So CS is equal to 0.1972. So next step will be to determine effective seismic weight of building, which is W. So from the section number 12.7.2. So here, this is the section number 12.7.2, which is for the effective seismic weight of the building W. Of a structure shall be included the dead load defined in the section number 3.1 above the base, and other loads above the base are listed below. So basically, in order to calculate the seismic weight of building, you have to include the dead load of the building, which is above the base, like above the foundation level. Whatever the load of building will be there above the foundation level, that you have to include in the seismic weight calculation. And then after, whatever the loads you apply apart from the dead load, which are going to be on the above the foundation level, that one also you have to include. For example, you are going to apply the dead load you have applied. Okay, so you have to consider that anyway. Then after, you have to also include the live load. Okay, and if you have applied the snow loads and all, also you have to include that. So here some conditions are given in the areas used for the storage. The minimum 25% of floor live load shall be used. So basically, we have to use 100% of dead load and the 25% of live load in order to determine the effective seismic weight of building. And here some exceptional cases are there, where the inclusion of a storage load add not more than 5% of effective seismic weight at the level. It need not to be considered, okay, in the effective seismic weight. Okay, like if you say the storage loads are very less amount, okay, so you can just neglect those for the seismic effective weight calculation. Now, the floor loads on the public garages, or you can say the open parking structure, need not to be included in the seismic weight. So you don't have to include the live load which you have applied for the public garages, or you can say the parking floors. You don't have to include that for the seismic weight calculation. Now, the second one is like where the provision of the partition is required. Okay, like partitions are nothing but the primary wall, or you can say the partition wall you are going to provide in the building, is required by the section number 4.3.2 in the floor load design. An actual partition weight, or you can say the minimum weight of 10 PSF, or you can say 0.48 kilonewton per meter square of a floor area, whichever the greater. So basically, here in this case, if I tell you the simple way, we have already applied the wall load on the beams only. So anyway, that will be considered within the dead load itself. Like we have applied the dead load. If you go for the ETAS model, okay, just right click on any particular beam. On this beam, if you go for the load section, you can see we have applied the dead load of 11 kilonewton per meter. This is nothing but the partition wall load only. So this load will be also considered in the calculation of the seismic weight of building. So basically, for the calculation of the seismic weight of building, you have to consider the wall load also. Now, then after, you have to consider the total operating weight of a permanent equipments. Okay, like you are going to provide certain equipments like the lift machine and all. Okay, so you have to consider the weight of those also. Then after, where the flat roof snow load, okay, PF exceed 3 PSF, or you can say 1.44 kilonewton per meter square, 20% of the uniform design floor load shall be considered. Okay, so if you have applied snow load on the building, okay, and it is, let's say it is more than 1.44 kiloton per meter square, then in that case you have to consider 20% of the snow load. And if the snow load is less than 1.44 kiloton per meter square, then you can just neglect it in the calculation of the seismic weight. Then after, weight of a landscaping, or you can say the other materials at the roof garden and the similar areas. So if you have provided the landscaping and all about the roofs and all, so you have to include the weights of those also in the seismic weight. So for now, we have not applied any kind of snow loads and all. Okay, we have just applied the super dead load, or you can say the dead load and live load. Okay, so dead load we have to consider is 100%. Then after, a 25% minimum of the live load we have to consider. Okay, like 25% minimum we have to consider live for the seismic weight calculation of the building. Now, how you can calculate the seismic weight of building is, here is a formula. Seismic weight of each floor, first of all, we'll calculate. So this is the formula: floor area multiplied by 1 into DL. Here DL is nothing but the dead load, and LL is nothing but the live load. So 1.0, you can see this is nothing but the scale factor for the dead load. Like 1.0 we have to use when we are going to consider 100% of dead load. And for the seismic weight of the building, we are going to consider 20% of the 25% of a live load according to the code. Right? So here, multiplier for the live load, we have to keep it as a 0.25, as we are going to consider a 25% of live load. So according to the floor area and the dead load given here on the on floor is 15 kiloton per meter square. Then after the live load given is a 12 kiloton per meter square. So according to the load conditions and these floor areas, the seismic weight of one floor will be calculated. Okay, we will use the calculator also in order to determine that. Okay. For example, let's calculate the floor area first. So the length and width we have to consider in order to calculate the floor area. So 15 meter multiplied by 25. So floor area is 375. Okay, now we need to multiply with the 100% of dead load and the 25% of live load. So then after dead load is 15. So 100% we have to consider. So 15 kiloton per meter square is a dead load on every particular floor. Then after the live load is 12 kiloton per meter square. But for the calculation of the seismic weight of a building, we have to consider 25% of live load. Okay, so dead load is 15 plus 25% of the live load, and live load amount is 12 kiloton per meter square on all floors. So here 18 is there. So now we have to multiply this with the floor area, which is 375. So 6,750 kiloton. This is the seismic weight of one floor we are getting. According to this formula, floor area multiplied by 100% of dead load plus 25% of live load. According to this, we are getting the seismic weight of a one floor as a 6,750 kiloton. Now we have to calculate the total seismic weight of building. Okay, right now we have just calculated the seismic weight of one floor. So we have the 6 floors here. G plus 5 building is this. Okay, so total number of floors are 6. So number of floors multiplied by seismic weight of a one floor. Using this one, you can determine the total seismic weight of building. For example, the seismic weight of one floor we have got is 6,750 kiloton. Now just multiply with the total number of stories. So total number of stories here are 6. So 40,500 kiloton is the total seismic weight of this building we are getting. Now to calculate the seismic base shear, which is nothing but the seismic force at the foundation level. The formula is this one only. We have seen in the section number 12.81. Now we have already found out the value of CS, which is the seismic coefficient, and W is nothing but the effective seismic weight. We have all these two values. So according to these two values, you'll get the value of the seismic base shear. For example, let's say the CS we have got is a seismic coefficient is like 0.1972 multiplied by the seismic weight of building is 40,500. Okay, so 7,986.6 kiloton is the earthquake force. Like this is the minimum earthquake force will be applied on this particular building.
So that's it in this video. Thank you so much for watching. If you found this video helpful, then please like, share and subscribe to our channel so that you can get notified for the videos that we'll be uploading in the future.